It's a good habit always before we start our work to revise through a system. Hi, I'm Mr. Long and I'm a science teacher today. Now let's take a look at the electrical system now in this video. Let's revise what we have learned from left to right of this page. You may have your book in front of you as you watch this video. Now, electrical system. We learned before the sources of electrical energy. So where can we find electrical energy? Well, a battery will have stored energy that can be converted into electrical energy. Lightning, of course, is a very natural source of electrical energy, and don't get struck by it. A power station can generate electrical energy. A solar panel can convert light energy from the sun into electrical energy. This is another form of natural source of electrical energy. So this will be the man-made sources, and this would be the natural sources. We have learned that in a simple circuit, you have batteries, you have wires, you have bulb. A switch may or may not appear in a simple circuit. One of the simplest circuits you've learned is called a circuit where you have all the components in series, right? So, and if these are all connected properly and this switch is closed, you have a closed circuit. Alright, and a closed circuit, the bulb will light up in a closed circuit. Now, and how can we increase the brightness of the bulb? When we increase the number of batteries, the brightness of the bulb will increase, because more batteries means there is more stored energy that can be converted into electrical energy. We will learn more about this idea of stored energy when you're at P6, learning about forms of energy. Now, of course, you may also remember the drawing inside your learning log. What is a light bulb? It has many parts to it, right? There's a filament inside, right? And this is a metal casing, and this will be the metal tip. And this is a transparent glass, and you know why it's glass, right? So it's a transparent material, so light can pass out from it, so it can shine into wherever we want to shine on. To light this light bulb, we need to pass electric energy through the wire, let's say through the metal tip, up to the filament, and down to the metal casing. Therefore, the bulb must be connected at two places, one at the metal tip and then at the metal casing. What happens when you put bulbs in series? Well, the more bulbs you put in series, so here there are two bulbs in series. We talk about using the word loop in our practice in the science lab. Here there's one loop, there are two bulbs. What if I put a third bulb? Will the brightness of the bulb increase or decrease? Of course, it will decrease. And the greater the number of bulbs, the dimmer the bulbs, because then the amount of electrical current flowing through each bulb will be less. What's the disadvantage? If just one of the bulbs is to be spoiled or fused, then the other one will also not light up. If this bulb, for example, fuses, what happens is that the circuit will now be an open circuit, and then current cannot flow through it. So for example, an open circuit, bulb does not light up in the open circuit. Now, what happens when bulbs are in parallel? Now this arrangement is actually what you will find in your homes. Alright, so even let's say this is the top bulb and the bottom bulb. If the top bulb were to fuse or to be spoiled for some reason, this bulb can still light up if this switch is closed, right? Because current can still flow through in this circuit. Not here, oops, not here, because it is fused, right? When this is arranged in this way, one loop and two loops, this will be bulbs in parallel, and the bulbs will be of equal brightness. And that's the advantage. So even when one of the bulbs fuses, the other one remains lit. How do we know whether a substance or material is an electrical conductor or not? Well, we just use a circuit tester. A circuit tester is made of a very simple thing with a light bulb, a battery, and a couple of wires. We just attach these two wires to two ends of this material, and if this material is an electrical conductor, electrical current will pass through it, through a filament, the bulb will light up. If this material is an insulator of electricity, then electrical current cannot pass through this. Electrical current cannot pass through this material, and then of course the bulb will not light up. So we observe this. If the bulb lights up, then of course the material is an electrical conductor. The bulb does not light up, the material is an electrical insulator. Now, we've learned how to handle electrical appliances safely. We should not overload any sockets with many appliances. If the wire is frayed at some point where there's exposed wires, we do not touch or use such wires anymore, and then replace or changed. And do not touch any electrical switches or connectors with wet hands, because when our hand is wet, that causes our hand to become a very good conductor of electricity. Now, we also learned that we should conserve the use of energy in our homes. So if you're not watching television, if you're not using the air conditioner, if you're not needing the fan, switch them all off. Okay? Now that's all for the revision. And let's move on to the work here. Now Gopal set up 3 electrical circuits using identical batteries and identical bulbs. The batteries and bulbs are working properly. Okay? So now you've identified this will be your bulbs is in arranged in series, bulb in series, bulbs in parallel. Which of the following shows the correct order of brightness from the brightest to the dimmest? Well, I see. We must always compare when we are given 2 or more diagrams. Let's compare across this. There are 2 batteries here. You can write this down, please. 2 batteries here, and here 3 batteries. Plus, minus, plus, minus, plus, minus. A lot of batteries, right? We learned before that if we want it to be bright, right, the greater the number of batteries, the brighter the bulbs. So let's see if this is true here. What is the most number of batteries? Great. And these 2 bulbs will be of equal brightness. Therefore, even if I were to remove this bulb will still light up, and it will light up with the brightness of that's equivalent to me putting 3 batteries there. So this bulb can only light up to the brightness of that's equivalent to 2 batteries. So this will definitely be the brightest bulb. Okay, and since these 2 are working and they are of equal brightness, therefore bulb C should be the brightest. Let's check. There's only one in bulb C, the brightest. Now we're going to check the dimmest. Now these 2 batteries are the same number of batteries here. There are 2 bulbs here, more bulbs in series. Now what did we learn earlier on? The greater the number of bulbs in series, the dimmer the bulbs. So therefore here, this will be the dimmest. Alright, and compare between these 2, bulb B will be dimmer than bulb A. Therefore, yeah, this is the dimmest. So answer is 4. Next one, the following diagrams show what happens when different types of material P, Q, R, and S are connected in a circuit. Let's see what happens. When these 2 are connected, the bulb did not light up. This can mean 2 possible things. Number 1, 3 possible things. Maybe P is not a conductor of electricity. It's an insulator. Or maybe Q is an insulator of electricity. Or maybe both are insulators of electricity. We don't know. But let me skip to this. When I connect the batteries, the bulb, and these 2 materials together, the bulb lights up. That tells me P and S must be conductors of electricity. If P and S are conductors of electricity, let me write this down. This will be a conductor. This is a conductor and S, right? But the bulb did not light up in these 2 circuits. That means that Q must be an insulator of electricity, and R must be an insulator of electricity. So which materials are electrical insulators? It must only be Q and R. Okay, these 2. So that's your first part of the answer. First question, first answer. Explain your answer. Well, bulb. Let's just write it clearly. Bulbs lit up when, only one bulb. Bulb lit up when P and S are connected in the circuit. What does it mean? Meaning P and S are conductors of electricity. Right? We must always specify that they are conductors of electricity. Otherwise, people may be confused. They think they could be conductor of heat. Okay, so we must specify their conductors of electricity. So bulbs lit up when P and S are connected in the circuit, meaning P and S are conductors of electricity. But hey, Mr. Long, you're not explaining why R and Q are electrical insulators. We will get there. We must first establish that these two are conductors of electricity. Then, when Q and R, which is now we're talking about these two now, are connected to P or S in a circuit, the bulb did not light up. Okay, so when you connect Q or R, right, in a circuit, the bulb did not light up. That means that, meaning Q and R are insulators of electricity. This answer is a bit long, but learn how to answer it in this way. Right, you may pause the video here to write down all of this. The circuit diagram shows three identical bulbs, A, B, and C, arranged in two different circuits, D and E. Right, these two circuits. The battery and bulbs are working properly. Explain what will happen to the other bulbs if bulb B in each of the circuits fuses. Let's check. Bulb B is this, bulb B is this. So let's check the easier one first, because we learned this earlier on, right? When bulbs are arranged in parallel, when one of the bulb fuses, the other bulb remains lighted up. So here, if this one were to fuse, electrical current can still flow through bulb A in the first loop, it can still flow through bulb C in the second loop. Alright, it won't flow through bulb B, but it can still flow through these two. So these two will remain lit. So in circuit E, what will happen to the other bulbs? They will remain lit. Okay, some of you may say lighted up, but remain lit is also fine grammatically. So what will happen if this bulb were to fuse here? This is a single loop. This is bulbs arranged in series. Then electrical current will not be able to flow through B at all. And when that happens, this is what we call an open circuit. So no current can flow through. If it's an open circuit, what happens? The bulb does not light up. Okay, remember when one of the bulbs fuses when they're arranged in series, the other bulbs are not lighted up. So here, they will not light up. You cannot say that they will fuse. Right? Fuse means that the filament will melt. When you say a bulb fuses, it means this part here, the filament actually melts. So in this case here, if bulb B were to fuse, A and C will not fuse. They just will not be lighted up, that's all. Alright? Now, last part here. Bulbs A, B, and C are arranged in a new circuit here, where the smallest and the largest number of bulbs that remain lit when one of the bulbs in the circuit is fused. So for example, if bulb C fuses, if bulb B fuses, for example, here, it's gone. Alright? Then in this part here, electrical current cannot flow through. But here, yes, it will flow through. So yes, one bulb still remains lit. Next one, if this bulb were to fuse, then current cannot flow through this part, but current can still flow through here. So two bulbs remains lit. What if this one fuses, A fuses? Well, current cannot flow through A. Alright, this one will not be lit, but current can still flow through this portion, so bulb C will still be lit. That's why two bulbs here. Okay, make sure you complete your corrections before coming to school. See you soon.